WarsawJS.
Let's start with my presentation, which is about a pretty controversial topic. Some say it's even more controversial than the division between people who prefer new and old Star Wars movies, and its usage of JavaScript language in embedded applications. Here is a really short resume of mine. I graduated electronics, long time ago. Okay, I get the point. Back in times, you have paper notes during studies. I do, a lot of C, C++, and Linux things. I work in SoftServe, which seems to be one of today's sponsors as an IoT expert. And my knowledge about JavaScript mostly boils down to reading JavaScript, the good parts, and having many friends who write in JavaScript. And when we meet and complain about more or less the same things, so I think that there is at least some basic understanding of embedded people and front-end people, as well as the full stack ones. Here was the survey, but let's do it live, not to log to anything. Has any one of you wrote some C or C++ code? Whoa, much more people than I expected. Have you ever tried to program microcontrollers in JavaScript? Have you ever struggled with memory management in pure C? Okay, we might have a therapy talk offline about this topic. So here's my agenda in a really shortened way. There will be many oversimplifications because we have half an hour and not 3 hours, unfortunately. I will tell what are embedded systems, especially the modern ones. Why is usage of JavaScript and Node.js in embedded systems both a very good idea and a terrible idea? And I will show you some real-life examples of devices running JavaScript and being actually widely used in the field, both for hobby projects and nowadays also for commercial ones. Here is also my hidden agenda. It's to encourage you to try out some new things, get some new knowledge, and do all of it with some knowledge you already have. So yeah, I hope you will jump into the rabbit hole as I did like 15 years ago. Here's a very short and very simplified history of embedded systems. I think this picture says it all. Here you have an Apollo guidance computer from the moon mission in 1966. It had 4 kilobytes of RAM and 2 megahertz processor. That's not a lot. And here's Amazon Echo, which everyone says at home. Here is Amazon Echo from Alexa, which many of you use to buy things online, and this small device has 2 gigabytes of RAM and 2 gigahertz processor. So here may be a question, oh my God, how did they made it to the moon with such small amount of memory? Well, actually, the answer is pretty straightforward because in space, many things are deterministic. So if you know when you are, where you are, and when, it's pretty easy to navigate. However, still, the code of this computer is a masterpiece, and I bet that many weird assembler tricks were made them to even make it possible. And here's also a completely new concept of Internet of Things. So if we consider a single microcontroller like a building or a single black rubber duck, as it was shown today, Internet of Things is a full city, school of fish, or what is the name for a crowd of ducks? I don't know. I only know that for crows it's a murder because it's funny. It's like a whole modern city of many devices interconnected with each other, exchanging information in many different ways. And well, the task of a single microcontroller is not anymore one small thing like changing the room temperature basing on the thermostat settings. It's much more complex. And right now, there are around 27 billion of devices connected to Internet of Things. However, the market is growing really rapidly, and there are some expectations that there will be even 1 billion devices by several years. So, well, that's a lot. Project management people may say, whoa, that's a lot of tasks into a backlog and many work hours. And yeah, it's right. Somebody needs to sit down and actually make it happen. And most probably this will be us. But here's the main problem. Oh, I will try to use the pointer. Yeah, I did it right. Here's the main problem with low-level C and C++ application. You most probably know this picture. I also use it as a template for many of my memes. And the C code may run really fast. It's really energy efficient. But, well, there are some issues with portability. I may tell you about my latest projects. For example, when we upgraded the compiler by one version, and it broke so much that we spent several weeks of fixing things, which actually turned out to be turning warnings off because all warnings were treated as errors. Anyway, there is an issue with how fast are we able to create a code which well, won't crash and burn within the first days of its actual usage. And yeah, as you might have probably already guessed, there are many challenges in the embedded systems industry right now. These are not all the challenges, but the ones relevant to today's topic. Code is not really portable. Everything what needs to be done low level needs you to be really familiar with the architecture, spend a lot of time with data sheets, and then be really angry because you shifted a bit in the wrong way and you made something crash. Maintainability of devices working in the field is, well, also messy. Imagine that you have a mesh of sensors somewhere in the field, like agricultural ones, and somebody needs to go and somehow upgrade them. If you need to do it manually and you don't have the so-called over-the-air upgrade possibility, you need to delegate some poor guy with a flash USB stick to manually upgrade all of it. And I assure you, this guy won't be happy with this task. And right now, well, there is known problem of hardware shortage. From what I remember several months ago, it was literally impossible to buy even simple evaluation boards like Raspberry Pi. And as I mentioned before, most probably many people know it from their own experience, there is an incredible market demand. However, the development process is slow. And yeah, many security issues, just like in literally every programming languages. As my boss says, the S in IoT stands for security. If you don't believe me, you most probably remember all the cases when somebody broke into some Fort Knox level of system by hacking a driver of a pump in a fishbowl. And there were many situations like that. Sometimes it was an USB wireless kettle. So it's still happening, and it's not good that it's happening. So here is a really nice chart showing how the mindset of programmers is actually shifting, because these are top technology challenges from embedded.com website survey. The ones in, let's say, red are from 2009, and the ones in blue are from 2019. So back in the days, it was a real challenge to manage the code size, to obtain software tools. I guess it was about writing everything from scratch or reinventing the wheel, integrating things and building process. Right now it has changed a bit, meaning that people are not so scared of their, let's say, legacy code base or learning new tools. However, they need to deal with low power and, yeah, as I said, security concerns. Yeah, low power is also a big topic, especially if you are creating some devices which need to stay up for a long time. And here's the topic of applicability of JavaScript in embedded systems. For context, I remember that 10 years ago, when I graduated, I was searching for a job and I found an offer for embedded JavaScript developer. I said, no way it's possible. Then I went to my friends from the university and I graduated electronics. So we mostly did assembler, VHDL, and sometimes some C. C++ was too high level for us. And they also said, no way. But now I see more and more actual applications of JavaScript, which are really great and they actually make sense. So why is JavaScript considered in some applications on some life cycle of them? There are, well, more experts in the job market. I would say much more. It's really difficult to recruit a developer specializing in low-level programming. Memory management is, well, easier, but it's oversimplification because it's easy if you just want to let garbage collector do their thing and it's all. You don't have to manually allocate and then deallocate memory and then run Valgrind and have terrible errors and have nightmares about them later on. Development is, well, much faster. I wanted to find some actual data to back it up, but there's no such research. Only there was one research that shows that number of lines of code written per hour is more or less the same in every programming language, and it's much easier to accomplish a lot in not many lines of code in scripting languages than in like traditional imperative paradigm C. A firmware upgrade is much easier. Why is it much easier? Because most probably, if you are running scripts, you just need to upgrade the script, which is a text file. It's most probably the same batch file for many devices. In case of binary upgrades of the application, well, it gets much more messier. However, the topic of firmware upgrade in Internet of Things is difficult. Now I'm looking at this poor guy I mentioned before with this USB stick who needs to go through the field and do all of it manually. It's portable because you run it on a virtual machine. You don't run it on one particular architecture and it only works there and it crashes elsewhere. Virtualization is easy. NPM has an incredibly big package base. I know that many people find their quality debatable in many cases, but imagine that you can test something locally on your PC, and when it works, you can just deploy it to your microcontroller and be happy that it works in the exactly same way. Well, you have a REPL. It's also a really useful thing, especially if you just want to play around with the hardware. And event-driven frameworks are like magic for all sorts of connectivity application, especially when they need to handle large peaks of incoming data. If you want to write a basic event loop in C, then, well, it's much more difficult. At least I have never saw a great implementation of event-driven architecture, unless you really like to write callbacks or function pointers, and I don't, let's say. And yeah, then what's the catch? What's not as perfect, and why don't we just throw away all our previous code base and switch to JavaScript? Well, it was created for browsers, not for operating systems. Here, the counterpart may be that, okay, but C or assembler was created for simple microcontrollers and not for this combined type of microcontrollers doing everything, handling network traffic, and so on. Its runtime performance is not really good. However, still, according to some research I found, it's twice faster than Python due to a better memory management. Its memory handling, it's done undercover, so that if you want to write some particular value into some particular register, you most probably need to use some frameworks which are implemented in C anyway. Resource consumption is pretty big, but still a bit better than Python. Multi-threading is complicated. Well, I'm not really familiar with JavaScript model of multi-threading. From what I remember, actually undercover there is only one thread. So it would also allow some wrappers to make it run in a multi-threading environment so that it won't break things. Security is an issue. I will get back to it on the next slide. And energy efficiency is worse than in system design languages. It needs to be considered if some really low power and low energy power application needs to be written. But still, it's slightly better than Python, at least according to some benchmarks I found. Regarding experts in the job market, here is a nice chart from this year's Stack Overflow's annual survey regarding people who program as a profession. There are, I would say, like more or less 3 times more JavaScript engineers than C++, at least on this platform, and around 4 times more than C experts. Still, what's interesting is that it's a chart for people who are already programmers. I'm afraid that these numbers are even more divided for people who are newcomers and just want to write something, because it's much more interesting to see something you implemented works on a website than to wait for a microcontroller to arrive, then connect it, then something's not working, checking the electric scheme, and just this testing and writing or TDD loop is much longer, so to say. And there's also a nice chart about language security from Ment.io's white source security report. JavaScript. JavaScript is in white here. C is in almost the same purple as PHP. However, you can see that many vulnerabilities are being detected in C. This may mean that C's memory management level or easiness of doing a buffer overflow is really possible, but sometimes somebody may also say, okay, but C programmers are just more cautious and report more errors. Anyway, it's just a threat in all the cases, so there is no silver bullet for that. No matter which language you use to do some IoT, you need to be really cautious not to disclose too many things. There are many popular libraries used commercially for JavaScript in embedded. They are mostly connected to Internet of Things. What is cool, because it's really easy to develop some small sensor, then try to integrate it into your smart home application and just be happy that it worked and that you did it on your own. Also that if it breaks, it's you to blame and not some producer you don't know. There's a nice engine developed by Samsung, which is, well, this Samsung. It's named JavaScript. There's a cool platform for robotics named Johnny 5. Actually, I wanted to present you some usage of Johnny 5 on Raspberry Pi today, but we don't have 3 hours, as I said. If anyone is interested, you may try to catch me offline because I have my board with me today. And there's an awesome solution named Node-RED, which is, so to say, high-level but low-code solution for various platforms where you can model some workflows. And it looks really cool, especially for prototyping your ideas for applications. Then there's also a start that if you think that, yeah, it's cool, so how should I begin? Then here's why. Here's how, not why. There are 2 really great evaluation boards easily available on the market despite the current hardware shortage. There is ESP32, which is crowdfunded, and several versions of this board were fully crowdfunded. Nice board with an extension in JavaScript. It has a cool web IDE. And there's also a Tessel2 board, which is a bit bigger. Last slide. And it comes with some long-term support version of Node.js. Final thoughts, I need to skip this, but these are quotes from the books about JavaScript for web developers. And there was also a really nice quote of an ex-ARM employee who decided to be a CTO of a company actually doing embedded JavaScript. That TLDR version is that even if, like in our team, C and C++ will be the main, JavaScript will be a really great support player in many cases, and it's really interesting to see where it goes in next years. Thank you.
Don't go anywhere. Don't go anywhere. You are a really great presenter. Jestem podwrażeniem. I'm sorry. I'm really impressed by your presentation skills. A couple of things terrify me. I'm going to take some questions. Anybody get questions? The idea, first of all, I am a walking, how do you call it, legacy hardware. Yeah, this is me. It's old. It's difficult to update. I understand front end. I understand back end, but this embedded thing terrifies me. Okay, here we go.
So how do you handle the fact that JavaScript is like loosely typed and like
actually, a friend of mine is doing an application which uses TypeScript. However, it would really be a mess, especially with JavaScript evaluation of conditions. For sure, if you want to run it on embedded, it needs to be somehow compilable. Actually, what is done undercover in many cases is that this JavaScript is translated to C anyway.
Next question.
Okay, so what does the job market for embedded JavaScript looks like? Is it on decline or is it growing right now?
Right now, I remember several projects. What I see is that there's a large market for IoT specialists or they both cloud and edge part of IoT, and yeah, it's strongly dependent on the projects. I don't recall seeing many job offers for that, apart from this one company which I mentioned before, but it hops from time to time. One of my previous companies actually had a really big embedded JavaScript team, and it was 5 years ago.
This whole idea of being controlled by my devices, I'm nervous, people. I got to tell you, is this the future? Is this what it's going to be?
Yeah. Thank you for the presentation. And I would like to ask, in what cases we should use JavaScript for embedded? Because what comes into my mind is to use like C or C++, which everybody uses. So in what cases is JavaScript really better?
Today, when I was in the train commuting from Wrocław in here, I actually saw a really nice summary. It's somewhere on YouTube from a company which decided to switch to Node.js on embedded, for better or for worse. And they said that, first of all, it's up to the team. if you don't need to meet some strict requirements of real-time operating systems, that you need to keep tight deadlines of finishing each task, or you don't need to do any resource-critical, time-critical operations, then yeah, it's fine. As an experienced embedded developer, I would say that JavaScript would be cool for some short-term products or like pilots where you just want to say integrate several things, do it fast, just to see if it works, and if it doesn't, then no worries. Similar cases, what I was also doing some time ago is prototyping for something which will be rewritten in a different language anyway, because right now we are just testing different solutions of some or versions of some algorithms.
Wow. Anyone else have any? We have time for one more question if someone has one. All I can say is I think JavaScript.
JavaScript and Rust. Rust is also an amazing thing.
And Rust. This is WarsawJS. What does that stand for? JS, right? That's JavaScript, right?
There is R.
JavaScript. JavaScript. Thank you very much for your presentation. Give her a big hand, everybody, once more.